Next, the calculation of delta rho. Equation is rho into delta S by S plus 2 into delta R by R plus delta L by L. Here, L is the length of the wire. Length of the wire is 200 centimeter, and numerator is delta L, that is the least count. 200 centimeter, that is measured by using meter scale. So the least count of the measuring device is 0.1. Next one is delta R by R. R is the radius of the wire. Radius of the wire is 0.022 centimeter, and delta R means the least count error of the measuring device. Radius is measured by screw gauge. Its least count is 0.001. So 2 into 0.001 divided by 0.022. Next one is delta S by S. So here there are 5 observations, and also there are 5 different values of delta S, and 5 difference of S and rho are there. So by putting them in this equation, suppose for example in the case of the first observation, delta S we have already calculated, that is coming as 0.0952, and the corresponding S is 11.71, and the corresponding rho is 8.89 into 10 raised to minus 7. And here this quantity, that is 2 into 0.001 by 0.22 plus 0.1 by 200, it will be constant for this all the calculations. When you are going to calculate this delta S for 5 observation, in all the cases this part, that is 2 into 0.001 divided by 0.22 plus 0.1 by 200 will be common. So only we have to change the values of delta S and rho. So for the first case, 8.89 10 raised to minus 7, there is a rho. 0.952 is delta S, and S is 11.70. By doing the calculation, finally we are getting the value of delta rho, that is equal to 8.85 10 raised to minus 8. The second delta rho, there are 5 observations, so therefore we have to calculate the delta rho for all the observations. Second delta rho is same equation, but only one change is rho in the second case is 9.28 in 10 raised to minus 7, and delta S is 0.098. Previous case it was 0.0952. Second observation it is 0.098 divided by S is 12.21. And there is no change. I already told you there is no change in the remaining portion, that is 2 into 0.001 by 0.022 by 0.1 by 200. So after simplifying, we will get the answer of the second delta rho, that is equal to 9.23 10 raised to minus 8. This is the case of the second one. Third error of rho can be also calculated like this, and the fourth one and the fifth one. Okay, fifth delta rho. And finally we have to write the result. The result section we have to write the unknown resistance S plus or minus delta S. Here S means the average value of S. There are 5 S values are there. In the table there are 5 S values we have written. Averages of this all the S, adding this all the 5 S and then dividing by 5, we will get the average value of the S plus or minus. Delta S means the maximum value of delta S. There are 5 delta S in the table. The maximum value of the delta S in the table is 0.108. That is the first result. Next one is resistivity of the wire. Resistivity of the wire is rho plus or minus delta rho. Rho means that is the average value. There are 5 rho values are there. Average of these all the rho values, 5 rho values, adding these all the rho values and dividing with the 5, the average will be 95.7 in 10 raised to minus 8. Actually the value will be coming 9.57 in 10 raised to minus 7. So we can write this 9.5 in 10 raised to minus 7 ohm meter, that is the average. We can write in the form of 95.7 in 10 raised to minus 8 plus or minus the maximum value of the error in the case of the resistivity, that is delta rho, is coming as 10.08 into 10 raised to minus 8 ohm. Here the error in the resistivity delta rho is in the order 10 raised to minus 8. That is why we have converted rho also in the order of 10 raised to minus 8. These are the 2 results.